Welcome to the Fox One Corp series of SeeYou training videos. I'm Dave Springford. Please visit me online at www.foxonecorp.com. In this video, what I want to show you is how to use the Task tab of the Statistics window. To do that, the first thing we'll do is review how we can set up SeeYou that we have two windows present. So at the moment I have the map full screen, but I want to add the Statistics window and have both of them side by side. So the first thing we'll do is we'll shrink this down to half size the screen, and then we want to add the statistics window. If I just simply click on statistics, it will replace the contents of this map window with statistics. To add a second window, hold the shift key, and while holding that, click on the statistics icon. We now get our second window open. So we can position this window where we want it, and then increase the size so we can see more details. So now we have two windows side by side. In a previous video, we looked at this flight and we looked at the statistics from the flight tab. What I want to do is move across to the task tab. Before we do that, one important thing to review is that on the flight tab, the declared task is written in the second section here. And one thing that we should note is that down at the very bottom, it gives us a distance, a duration, and a speed. And at the top here, it tells us what type of task was done. And this was set up in the LX9000 as assigned area task, when in fact it was actually flown as a racing task or a speed task. So in the previous video, what we did was we went and changed our turn points into FAI sectors from the cylinders that were there. But one problem that we have is this duration of 5 hours. Since it was set as an area task, it has a duration. And so what it's done is it's actually to calculate this speed, it's taken the distance of 314 and divided it by 5 hours. And so that gives us a speed of 62. If we go to the task tab, we'll start at the top here. But one of the important things that we'll see while we're on the subject is that the duration was actually 4 hours and 22 minutes, not 5 hours. So this is going to have a significant impact on this overall speed of 62.8. And so what I want to do is I want to go in and find how can I change that to get SeeYou to show me my actual achieved speed. And so this is something you have to kind of know that SeeYou is telling you the wrong speed, so you know to go in and fix it. So to get to the task, basically I can double click in the statistics window and it brings up the flight properties dialog, and here's our task. It's set as an assigned area, so I can go ahead and change that to a racing task. And here in time, if I put 0 time, then it will just take the raw time that was used on the task and not stretch the flight out or the task out to 5 hours. So if I say OK on this, wait for this to update, we can see it's updated things, and now we have a speed of 72.6 miles per hour instead of 62 miles per hour. And we have a duration of 4 hours and 19 minutes on the task. So what we want to do is start up at the top as we did on the previous, and we can see the task distance, start time, the altitude at which we started, the finish time, and the altitude at which we finished. These are important if you're doing FAI records or badges where you need to have a maximum 1,000-meter altitude loss between your start and your finish. And again, you can go up here, the tools, options, general, and change your height units to meters if you want. So we've already looked at duration and speed. The next thing that we have, very similar to our flight window, we have our circling and our straight time. And we can see that these statistics are now related solely to the time between the start and the finish as opposed to the entire flight. So on this view under task, we can see the total circling time was 31 minutes or 12% of the flight for 3.3 knots and a total of 18 thermals. If we go back to the flight tab here and we look down at circling again, we can see that we had 49 minutes for 16% and 26 thermals. So there was a lot of time spent before the task started or before crossing the start line where a bunch of thermals were used to get in a position to start. So a total of 8 thermals reduced during the task versus the 26, including the entire flight. And so the statistics here, they also give us an idea of what happened in the straight. And so 88% of the flight flying straight versus 12% thermaling. And one of the more important statistics to look at here is the distance done. And so we had a 313-mile task and 341 miles was flown. And so what we want to do is we want to try and reduce this distance done to get as close as possible to the task distance so that we know that we are flying efficiently. But remember, we'll never get it exactly to the task distance because it includes the circumference of all the circles that were flown, as well as any of the deviations that we took going from cloud to cloud. So we'll never get it down to a zero deviation. But if we can get this value within 10%, so if we could get this within 31 miles of this 313, that would be a good flight. And in this case, that would take us to 344 miles. And so with 341 done, we're below 10% in terms of total distance done, and that's pretty good. The other thing we want to take a look at, average glide. So we want to make sure we didn't stop too often to thermal. We wanted to have nice long runs between our thermals. And then taking a look at the achieved L over D, in this case 131 for the entire flight. We can see that in rising air, we actually had a negative L over D, which means we gained height the whole time that we were flying in rising air, which makes sense. And in the sinking air, we had an L over D of 21. Won't bother going through the bottom statistics here. We've seen what each of these graphs mean. But what I want to do is go down to the next section because this part of the task window gives us the statistics for the entire task. Now we're going to break it down by leg. So we can go to the next yellow divider and we can see this is for the first leg from Rockton up to the first turn point at McCullough Lake. Gives us our distance when we started and finished that leg, as well as the duration of that leg and the speed achieved on that leg. So this is an important one to take a look at because it tells us which were our slow legs, which were our fast legs. It tells us again all of our circling and straight statistics. So we want to scroll down to the next and we can see the second leg. We can see its distance, we can see speed achieved. So the speed achieved on the second leg was actually a lot better than the first leg. And if we go back to our flight statistics, remember we have this wind component that we can see. And on the first leg, we actually had a mild 2 mile per hour tailwind. And on the second leg, we had a 6 mile per hour headwind. So taking those into account means that our 61 miles per hour on the first leg was not very good compared to our 73 miles per hour on the second leg, considering an 8 mile per hour difference in winds. So that's something that we want to review as we're looking at our flight. Scroll down to the third leg, and we can see on the third leg this was an 83-mile leg, and it was done at 84 miles per hour. So that was a good leg. One of the nicest things about this flight was an achieved L over D of 500 to 1 on that third leg. And pretty much all of the task speed was made up on this third leg. So the third leg composes this easterly leg down at the bottom of the triangle. And in fact, on this day, there was a nice convergence, sea breeze convergence that formed from Lake Erie that I was able to follow. And that's what's responsible for the nice statistics we have here. You can see there were only 2 thermals on this leg, and the rest of the time was spent cruising. So 97% cruising time on that leg. And finally, we can go to the last leg, and what we can see is that we had a short distance just to get home from the bottom corner of the triangle, and it wasn't particularly fast at only 77 miles per hour, but it was still above the average speed for the entire flight. The next thing I want to take a look at is the Phases tab on the statistics page. And what the Phases tab provides is a text description of the flight. And it breaks down every climb, every glide into its own line, giving us the begin time, end time. Usually there's a duration column in here, but I removed it so that I could fit everything on the screen. And it gives us our start and end altitude, the height that was gained or lost on that leg, average vario, netto, ground speed, average indicated airspeed, the distance between those two time points and your DH or your L over D during that leg. So with this, I don't find it exceptionally useful sorted in chronological order like this. So what I like to do is I like to sort it by one of the other columns. And we can do that, for example, we want to take a look at just our climbs. So if we click on the average vario header, what it does is it now sorts all the flights by the average vario. So we can take a look and we can see where are all the good climbs. This first one, if I just hover over here, you can see straight and the word toe. That's the arrow toe. So we'll ignore that first one. We can see really there's only one exceptional climb of 6.3 knots on this flight. And we'd say, well, I'd like to know where that was. So if I double click on this line, it actually moves the airplane in this view to the location of that good thermal. So we can see that good thermal was here. So if I go back to the toe and double click on that, you see that the airplane moves back over to the home field. So double clicking on any of these rows will move the plane to that point. So that's one thing I like to do is sort by average vario so that we can get an idea of where our good climbs were, how many good climbs we took, how many bad climbs we took. And so we can see a bunch of 1-knot climbs down here, which aren't great, but if we look at the time of most of them, they're before the start, not all of them, but most of them. And the other thing that is useful is to say, well, how much time did I waste by climbing a lot in weak climbs? And for that, I like to sort by this height column. And so we can see all the circling is at the top, and I start looking at these weak ones and say, okay, 1.8 knots, only 233, only 200 feet, 300 feet, 300 feet. So I didn't stop and waste a lot of time in small climbs. In fact, it's not until I really get above the 3-knot climbs where we start to see us taking deep climbs. The rest of the climbs were either just to get in a position to move on, or they were just sampling the sky. Another nice statistic to sort on is the distance done, and that tells us how far we flew between thermals. And so this is a nice one to look at to see what were our actual glides. And so here's a nice one, 75 miles. Right now our glider's over near the southwest corner. If we click on this, we can see it moves down to about the middle of the triangle at the bottom here. And so when you click on a glide, what it does is it moves the icon for the glider to the middle of the glide. And so one thing we looked at before is up here, we can do previous thermal and next thermal. So we can look at this and we can click back and say, well, okay, I thermaled there just after I came out of the second turn point. And where did I stop and thermal again? We'll click on next thermal. And it's after I come out of the third turn point. And so that is indicative to us of our straight glide here of 75 miles, and that being at the middle of that glide. The other thing I like to take a look at on the glides is what was the achieved L over D on each of those glides. So I can put together nice L over Ds with long runs. Well, I hope that gives you some new information about how to use SeeYou, and you found that useful. Please visit me online at www.fox1corp.com. And if you have any questions, leave them in the comments below. And please subscribe to this Fox One Corp YouTube channel.